What are the electron and molecular geometries of the sulfur and oxygen atoms in sulfuric acid H2SO4? What are the hybridizations of the sulfur and oxygen atoms? We start by drawing the Lewis structure. When drawing Lewis structures, place the less electronegative element in the middle of the structure. Place the valence electrons in 4 even regions around the atoms. 2 electrons form a bond if the difference in electronegativity is 1.79 or less. Hydrogen and fluorine form only one bond, leave no unpaired electrons, and valence shell electron pair repulsion drives electron geometry. The sulfur atom is drawn, and its 6 valence electrons are placed in 4 even regions around the atom. The oxygen atoms are drawn around the sulfur atom, and each oxygen atom's 6 valence electrons are placed in 4 even regions around each atom. A hydrogen atom is drawn. Its valence electron is oriented towards an oxygen atom so that we will be able to make a bond between the hydrogen and oxygen. The other hydrogen atom is placed in the same fashion. We draw lines connecting dots between atoms. These lines represent bonds. On 2 oxygen atoms, we see unpaired electrons. We move these electrons together to create electron pairs. We redraw our structure neatly. This model shows the sulfur atom has both an electron and molecular geometry of tetrahedral. Notice 2 oxygen atoms have hydrogen atoms bonded and 2 oxygen atoms do not. The 2 oxygen atoms that have hydrogen bonded have a tetrahedral electron geometry and a bent molecular geometry. The electron geometry of the remaining 2 oxygen atoms is trigonal planar. The molecular geometry is linear. When determining hybridization, we must start with a properly drawn Lewis structure, ensuring the electron geometry is correct. Lone pairs of electrons are placed in hybrid orbitals. Electrons forming single bonds are placed in hybrid orbitals. For double bonds, one bonding electron pair is placed in a hybrid orbital. The other bonding electron pair remains in an unhybridized p orbital. There are no triple bonds in our structure. Hybridization is assigned according to the table below. If the electron geometry forms a line, then hybridization is sp and there are 2 hybrid orbitals. If the electron geometry forms a trigonal plane, the hybridization is sp2 and there are 3 hybrid orbitals. If the electron geometry forms a tetrahedron, then the hybridization is sp3 and there are 4 hybrid orbitals. The sulfur atom has a tetrahedral electron geometry. Therefore, its hybridization is sp3. The molecular geometry is also tetrahedral. The electron geometry of the oxygen atom attached to the hydrogen is tetrahedral. Its hybridization is sp3. The molecular geometry is bent. The electron geometry of the oxygen atom doubly bonded to sulfur is trigonal planar. Its hybridization is sp2. The molecular geometry is linear.